Welcome everyone to my talk today on composed multi-platform accessibility. So before I jump into things, hey, I'm Colin Marsch. I'm an Android engineer at Cash App. And while I don't work directly on composed multi-platform things day to day, I have been involved in some Kotlin multi-platform work, as well as I'm part of our accessibility working group. So sort of merging those two things together to talk about some composed multi-platform accessibility today. There's a bit of an overview of the talk today. I'll start with some composed multi-platform high-level overview. We'll talk about how it builds UI on Android and iOS. Talk about how composed multi-platform handles accessibility, and how we can test to make sure our apps are accessible when we're building composed multi-platform apps on both platforms. So firstly, what is composed multi-platform? It's probably something you've heard of if you were in the keynote speech as well. So at a high level, just a very simple explanation would be it's a composed UI way of building UI on Android and iOS and web and desktop, but I'll stick mostly to the mobile platforms for this talk, to be able to share your UI between platforms. So how I like to think about the distinction here, Kotlin multi-platform in general can sort of be thought of as shared logic, where you might want to hold some sort of data processing and share that between your Android and iOS apps to avoid duplicating code there. Whereas composed multi-platform allows you to share the UI that your customers will see when they are interacting with your application. So if we take a look at this snippet of composed code here, we just have a button that toggles a show image variable state, and an image is either shown or not shown depending on the state of that variable. This would be very standard composed UI code you could write natively on Android, but with composed multi-platform, we could also build this for iOS as well. So from this small video from the JetBrains documentation, we can see that this code we saw on the previous slide is running on both Android and iOS with the exact same UI representation and behavior on both platforms. Now, how does composed multi-platform actually do this? How is the UI built on Android and iOS? Well, on the Android side, it's just composed UI. So what was alluded to in the keynote as well, on the Android side of composed multi-platform, the regular composed UI toolkit that you would use if you're just building a native Android composed app is fully identical and would be no different if you're building the composed multi-platform version of that Android app. So even if you were to go ahead and build composed multi-platform app for Android and iOS and then decide to move away from composed multi-platform on the iOS side, you would still have a fully functioning regular native Android app. If we take a look at this main activity entry point for a composed multi-platform Android app, this set content block here with our app composable function in it, where the app composable function is sort of the root UI of our composed multi-platform UI structure. This is the exact same set content call that would be made if you're just building a regular native Android app fully built with composed UI. So there's really nothing special happening at this point, and just another example of how this is straight up just regular composed UI on Android. We take a look at what's actually created in the UI hierarchy as well. From this sample app on the left side with a bunch of sort of widgets of various styles defined. If we take a look at the Android Studio Layout Inspector, it's just the regular UI elements we would expect if we're using composed UI natively on Android. So we have our rows and columns and boxes and text and everything that's just standard composed UI with nothing special multi-platform baked in there. But what about on the iOS side? So on the iOS side, if we take a look at a similar entry point to the main activity one on Android, A view controller can sort of be thought of as analogous to an activity on the iOS side. This code snippet here looks very simple as well, and similar to the main activity entry point on the Android side. However, there's a bit more complexity baked into this Compose UI view controller, which enables us to pass in the exact same app composable function that we did on the Android side to use that Compose Multiplatform UI on our iOS app. So within this Compose UI view controller, if we dig deeper a few layers, we'll get to a lot of usages of this library called Skiko. And Skiko is the Kotlin Multiplatform library that enables the Skia rendering engine usage on the iOS side to be able to draw directly to the canvas for the UI representations of how we will present the UI on our iOS side. So drawing to the canvas on the iOS side has some pros and cons to it. There's a pro where we have now identical UI between platforms. Since we're just drawing pixels to the screen, we're going to have the exact same UI that we will have on each platform. Our UI also won't change during any OS updates, so if iOS decides to change what a button looks like in iOS 19 or something like that, that won't affect our app's UI at all. And it enables a bit less platform-specific code. Since this Skiko usage still lives within our Kotlin multi-platform layer, we don't have to worry about as much iOS side complexity as that gets pulled back into the shared code layer there. But there are some cons on the other hand. Potentially, there's some performance overhead depending on how expensive the state changes are in your UI. There's also a bit more interoperability complexity with native iOS UI if you want to have sort of Compose multi-platform in part of your app or part of a screen. It definitely can still be done and is something I'll talk about briefly in the next little bit here, but adds a bit of complexity to this piece if you compare it to just having fully native iOS UI in your app. And specifically for this talk, this adds a bit of accessibility complexity. Since we are no longer using any of the native iOS UI elements with all of their baked-in accessibility handling already provided through Apple, some of this has to be recreated, and luckily for us, Compose Multiplatform handles a lot of this internally, which is what we will get to shortly. So first, briefly to talk about the native iOS UI interoperability. The Compose Multiplatform framework provides a UI kit view composable function that may look similar to anyone who's used the Android view composable that sort of allows you to use native legacy Android views into a composable context. This is very similar in that you can just wrap a native iOS view into your Compose Multiplatform UI. So in this case, this MK map view is a standard iOS map that just displays a map of a location. And you can pull this into your Compose Multiplatform code here, apply any sort of modifiers you want from the Compose side, and then that will funnel up through your Compose states as you would expect if you were just building this using Compose UI. You can also use Swift UI with Compose Multiplatform. I'm not going to go too much into that. It's a similar concept, just building iOS native UI into your Compose Multiplatform UI. Now, how does this all relate to accessibility? So firstly, when you're building the UI of your application, that's really the time when you want to focus on the accessibility of the experience that your customers are going to be having, as it's the time where you have the most control over what their interactions are going to look like and how your customers will be able to achieve the goals that they want in your app, no matter what sort of assistive technologies they're using. I want to take sort of a platform-specific approach here to look at this. Start by talking about the Android accessibility tree briefly. So on the Android and iOS sides, the way that assistive technologies get their information they need to display all of the content, such as content descriptions or states or other values to customers using them, is through a tree of nodes relatively similar to the UI tree on both platforms, except these nodes contain just the information that these screen readers care about. So like I mentioned, content descriptions and other fields. On the Android side, the main data type for this tree is accessibility node info at the base level. So as I mentioned, this will include a lot of the fields that we need, like content descriptions, whether or not something is selected, if it has that ability, and if it's important for accessibility at all, or should be skipped when a customer is traversing over the elements in the UI. So all of these nodes will be traversed as you swipe left and right through your screen reader usage when going over your app. On the Compose side, however, on Compose UI natively on Android and in Compose Multiplatform, which again is relatively the same thing on just the Android side, we have the semantics node, which is the composable representation of the accessibility state of a specific UI element. So the semantics node can be updated based on the state of the UI through the same mechanisms that update the UI of your application that is actually displayed on the screen through composables. So this includes all the same properties that a screen reader might need, like the content description, the selection state, whether a UI element is a heading, and many other fields as well. So the semantics nodes form a tree based on the Compose UI that is created in your application, and these are mapped to the accessibility node infos that then get read by the screen readers that your customers are using on the Android side. So all the information there gets baked over into the accessibility node infos that are eventually used. And as I mentioned, Compose Multiplatform is just Compose UI on Android. So this is how it would work on native Compose UI on Android, and the same case will apply for Compose Multiplatform on the Android side. On the iOS side, the tree structure and how screen readers interact with it is all basically analogous. So just take a look at some of the data types and how this updating works. We have the UI accessibility element on the iOS side, which is analogous to our accessibility node info on Android. That contains fields similar as well, like accessibility label, which is the content description, accessibility hint, which describes what will happen when someone interacts with that element, and accessibility traits that contain many different properties, such as the selection state or many other things. So again, semantics nodes from the Compose side in Compose Multiplatform will be mapped to the UI accessibility elements within the Compose Multiplatform framework itself. So Compose Multiplatform will handle keeping the UI accessibility element tree up to date when your UI updates and that resulting from any state changes that might happen in your application. So there is one small asterisk here, is that this mapping is only done lazily. So this is for performance reasons at the moment. Perhaps these will be improved in the future, but right now this is only updated if there is an assistive technology connected, like VoiceOver on iOS. Otherwise, this tree may be delayed in its updates or miss some updates when states are changed. And on the mapping side of the iOS properties, since we are going from the Compose world in the semantics node to the UI accessibility elements, which don't have fully analogous properties, there is some mapping logic that is implemented in Compose Multiplatform to ensure that the iOS properties are fully filled with the correct data. So for just a couple examples on how these work, this is a snippet from the accessibility label function in the Compose Multiplatform code base. Here, the Compose Multiplatform framework overrides the accessibility label on the UI accessibility element that is used on the iOS side and pulls the correct data from the fields that are set in your semantics on your Compose Multiplatform UI. So for this specific case, first we'll check if there's a content description set on our semantics node If there is, then that will be used as the accessibility label. Otherwise, we'll see if there's some editable text here, like if we have a text field, or maybe there's just some text content overall if we just have like a text label in our application. For another example, for the accessibility hint, it'll look at if we have an on-click action and take the label from that, which is a way to describe what something will do when you interact with it on the Android side, and that is what accessibility hint wants to know about. And for traits, just as a snippet of a couple of those possible traits, if we have a semantics action for an on-click, then it will apply the button trait. If we have a heading property, then we'll apply the header as expected. And as I mentioned before, there is a possibility of using native iOS UI within your Compose Multiplatform UI. So Compose Multiplatform provides some accessibility handling if you want to customize how the accessibility works for these native elements that you bring in. By default, this is native accessibility enabled property is set to false when you use the UIKit view interop method here. In this case, the accessibility properties that are set on your native view, so in this case, any accessibility handling that's baked into the map view will be not respected in the UI, and instead all the accessibility information will come directly from your semantics on the Compose side. So in this example, our accessibility content description for the map view in this case will be map of NYC. Whatever is on the native side in the MK map view will be ignored. But on the other hand, if we wanted to use all our accessibility handling from the native side, we could set that flag to true, and then anything we have in that map view will be used in the actual screen reader usage our customers see. So this could be especially useful for very complex interactions, like a map, for example, which probably has drag and pinch to zoom actions that will be accessible through screen readers. Something like a web view is probably another good example here, or if you just built anything yourself already on the iOS side that is sort of complex and you want to bring that over to Compose Multiplatform, this enables you to do that without having to rebuild all your accessibility handling there in Compose. And now I want to talk about how we test our Compose Multiplatform accessibility. On the Android side, there's not too much special going on here. As I've mentioned a few times, it's just Compose UI on Android. So we can use the same tools like accessibility scanner that we would use to test our accessibility of our regular Android apps. This is just an app that Google provides that you can install on your device or emulator, and it will provide overlays if there's any accessibility issues, sort of in a pass-fail way, covering things like color contrast or touch target sizes, or if there's any missing labels. TalkBack is Android's main screen reader technology, and this can give you a bit more of a deep understanding of how your application is performing accessibility-wise. You can help you understand navigation issues or interaction issues. If you see when you're swiping through the hierarchy, if you're jumping around in a way that doesn't follow the logical flow of content, that can be an issue that could be resolved there. One way to contrast this with accessibility scanner is it's not sort of a pass-fail check, just tells you what this current state of your application is, and you'll have to interpret whether or not that's what you intended to build, and if that is an accessible experience for your customers. And on the automated testing side for Android, since we just have a regular Compose application, we can use the same things that we would use on the regular Android side. So we could enable our Espresso accessibility checks, which were recently had a new release to support Compose accessibility checks. That was a long coming feature and has now come out as of about a month ago or so. Paparazzi's accessibility render extension could also be used through just the Android side here to see what kind of accessibility labels are on your UI, and you can integrate some of these automated tests into your CI setup. On the iOS side, we have similar tools. VoiceOver is iOS's main screen reader technology, analogous to TalkBack on the Android side. So helps you uncover the same kind of issues like navigation issues or interaction issues, and also requires interpreting the results that you're seeing there. Something sort of specific to the iOS side is Accessibility Inspector, which is a Xcode developer tool that allows you to inspect UI on your machine. So if you're running an iOS app in a simulator on your laptop, you can then see in a visual representation here all of the content that would be read out by a screen reader. So in this screenshot here, we see the label, value, traits, hint, or anything else that might be set on our element. So this can be good for local development practices, just to sort of speed up your development there if you don't want to build to a real iOS device. And on the iOS side, automated testing is also available. The perform accessibility audit call can be made on your UI tests on the iOS side. This actually performs the same audit that the accessibility inspector I just showed can perform manually for you by clicking this run audit button. It does relatively the same kind of checks that you would do in your Espresso tests on the Android side for accessibility checking, or on accessibility scanner on the Android side. So it's things like the color contrast, if you're missing labels, things like that, sort of pass-fail detection of common accessibility issues. And one thing I want to call out, though, for the iOS simulator testing goes back to what I mentioned before about the lazily mapping from the Compose semantics node to the iOS UI accessibility elements. The Compose UI view controller that handles all of the UI construction on the iOS side has a flag you can set for accessibility sync options. If this is not enabled, that lazily updating of the accessibility tree on iOS applies. And since you are running the iOS simulator with Accessibility Inspector on your machine, unfortunately, this is not detected as an assistive technology being registered at the moment. So you will need to enable this for local development to be able to see the updates in real time to your accessibility tree. This does add some performance overhead, however, so would be something that's just recommended for development practices. And if you are building this to an actual iOS device and using VoiceOver there, then you don't need to worry about this flag and things will work as you expect. And before I leave off here, if anyone wants to learn more about Compose Multiplatform or its accessibility, I'd recommend first checking out the Compose Multiplatform repo on GitHub, which contains some example code and documentation for the Compose Multiplatform framework overall. As well, the internals of the Compose Multiplatform framework are all contained within the Compose Multiplatform core repo. So if you want to dive deeper into how some of this accessibility handling is built there, or just other internals of how Compose Multiplatform handles things, that would be a good place to check. And finally, tomorrow there's a talk specifically on Compose Multiplatform on iOS by Sebastian at 3:25. So I would recommend everyone to go check that one out. He's definitely an expert on the iOS side of Compose Multiplatform there. So that will be a really interesting talk to see. And that brings me to the end of my talk. So thank you. And I think we have some time for questions.